The tides stop answering. Not all at once, not dramatically, just quieter. The ocean pulls back a few centimeters less than yesterday, then a few more the day after. Fishermen notice first. Their tide charts, accurate for centuries, are suddenly wrong by minutes, then by hours, then by days. Nobody's calling it a catastrophe yet. Scientists have a name for what's happening. A slow, ancient, unstoppable process that's been running since the day the moon was born. The moon is leaving. It's already been doing it your entire life. Every single year, the moon drifts another 3.8 centimeters away from Earth. That's roughly the rate your fingernails grow. Quiet, unnoticed, relentless. But here's what nobody tells you. That number isn't constant. And the end game, what actually happens when the moon finally goes, is nothing like what you've been told. Stick with me here, because by the time this is over, you're never going to look at the moon the same way again. Here's the physics, and it's weirder than you think. The moon doesn't just orbit Earth, it pulls on it. That gravitational grip drags the oceans into two bulges, one facing the moon, one on the opposite side. But here's the thing, Earth spins faster than the moon orbits, so those bulges get dragged slightly ahead of the moon's position, and that misalignment, that's the engine of the theft. Those bulges pull the moon forward in its orbit, like a gravitational slingshot firing in slow motion. Every day, every tide, every wave that crashes on every beach on this planet is transferring a microscopic amount of rotational energy from Earth to the moon. Earth is literally handing the moon its escape velocity. And the receipt? Earth's days are getting longer because of it. When life first crawled onto this planet, a day lasted roughly 18 hours. Dinosaurs lived through 23-hour days. You're living a 24-hour day right now. In 200 million years, if this planet's still around, a day stretches to 25 hours. The moon is stealing our spin, one heartbeat of time at a time. But that's not the terrifying part. The moon controls the tides. You already know that. But the scale of that control is something your brain genuinely isn't built to process. The Bay of Fundy in Canada sees tidal swings of 16 meters. That's a 5-story building's worth of ocean rising and falling twice a day, every single day, driven almost entirely by the moon's gravity. The Amazon basin breathes with the tides hundreds of miles inland. Coastal ecosystems, mangroves, salt marshes, intertidal zones, they've evolved over hundreds of millions of years around the precise rhythm of lunar gravity. Remove the moon, those rhythms collapse. Not suddenly, not like a switch flipped off, more like a heart condition that quietly worsens over centuries. The tidal range shrinks. Species that reproduce by lunar cycle, horseshoe crabs, coral, entire categories of fish that time their spawning to the full moon, they lose their biological clock. The food chain doesn't break, it dissolves. And here's where it gets worse. Without the moon's tidal forcing, ocean circulation patterns shift. The deep mixing of cold and warm water that drives currents like the Atlantic meridional overturning circulation. The conveyor belt that literally keeps Europe from freezing. It weakens, not disappears, weakens. But in climate terms, the difference between weakens and disappears is measured in millions of dead. And we haven't even talked about what happens to the sky. Here's a fact that'll genuinely rewire how you see this planet. Earth's axial tilt, that 23.4-degree lean that gives us seasons, makes summers warm and winters cold, and has kept our climate oscillating in a survivable range for hundreds of millions of years, is stabilized by the moon. Pull the moon away and Earth's tilt doesn't stay put. It starts to swing, chaotically. Mars has no large moon. Over millions of years, Mars's axial tilt has swung anywhere between 10 and 60 degrees. Get this, at 60 degrees of tilt, a planet's poles receive more direct sunlight than the equator. Seasons don't just shift, they invert. Ice ages and heat ages cycle not over thousands of years, but over geological eye blinks. Scientists believe that's one of the reasons Mars lost its atmosphere. Its climate was never stable enough to hold one. Earth, without the moon's gravitational steadying hand, starts that same slow oscillation. Not tomorrow, not in 1,000 years. But over tens of millions of years, the tilt drifts. Climate belts migrate, rainforests where there were deserts, glaciers where there were rainforests. The planet wouldn't die, but the conditions that allowed us to emerge, gone. Probably forever. Wait. Before we get to the final phase, you need to understand what happens to your own body first. Close your eyes. Now open them. You're standing outside on a clear night, 2,000 years from now, in a world where the moon has drifted far enough that it looks like a coin someone glued to the ceiling. Too small, too distant, too cold. It's still visible, but it's wrong. Your instincts notice before your brain does. The nights are darker, genuinely, completely darker than anything your ancestors ever knew. Before electric light, humans navigated by moonlight, hunted by it, traveled by it. Whole agricultural calendars were built around it. Your eyes evolved over hundreds of thousands of years with the moon as a nightlight. They scan the horizon and find nothing to anchor to. The dark feels heavier than it should. And on certain nights, when Earth passes between the sun and the moon's new distant position, you'd look up expecting a lunar eclipse, that blood-red coin of shadow that humans have watched in absolute awe for all of recorded history. Instead, the moon just dims slightly, then brightens. No drama, no red, no totality. Because here's the thing nobody tells you about total solar eclipses. They only work because the moon is almost exactly the right size and distance to perfectly cover the sun from where we're standing. That cosmic coincidence, the moon appearing the same angular size as the sun, that's not a permanent feature of our solar system. It's a window, and it's already closing. Let's run the numbers. The moon recedes 3.8 centimeters per year. It's currently about 384,000 kilometers out. But here's where it gets crazy. The process isn't linear. As the moon moves farther away, its tidal influence weakens, which means less energy transfer, which means the recession actually slows down. The moon isn't going to fly out of Earth's orbit like a stone from a sling. This is a slow, grinding divorce, not an escape. And turns out the math actually points towards something stranger than the moon leaving entirely. In approximately 50 billion years, assuming the sun doesn't expand and sterilize this entire conversation first, which it will in about 5 billion years, Earth and the moon would reach something called mutual tidal locking. The same face of Earth would always face the moon. The same face of the moon, as it already does, would always face Earth. Two locked faces, staring at each other across the void. Tides would essentially stop. Not because the moon left, but because both worlds finally stopped fighting each other's gravity. This next part is the reason I can't sleep. We won't be here to see any of it. The sun will have already swollen into a red giant, evaporated Earth's oceans, stripped the atmosphere, reduced this entire story to a scorched rock drifting around a dying star. The moon's long goodbye doesn't end with it leaving. It ends with us going first. Here's the revelation that nobody frames correctly. The moon you're looking at tonight, right now tonight, it's not the moon your grandchildren will see. It's not the moon their grandchildren will see. Every single generation of humans that has ever existed has looked up at a slightly different moon. Slightly closer, slightly larger, slightly more gravitationally dominant than the one that'll rise tomorrow. The ancient humans who painted animals on cave walls 40,000 years ago, they looked up at a moon that was 152 centimeters closer than yours. That sounds like nothing. And yeah, in human terms, it basically is. But here's what it actually means. The moon as you know it, this specific moon at this specific distance, capable of total solar eclipses, capable of the tides that built every coastal civilization in human history, capable of stabilizing the axial tilt that made complex life possible in the first place, this version of the moon isn't the solar system's default setting. It's a moment. We just happen to exist inside it. Every culture that's ever existed on this planet built something around the moon. Calendars, religions, myths, the Islamic calendar, the Hebrew calendar, Easter, Ramadan, the Chinese Mid-Autumn Festival, the Greek word for month, Mayas. It's the same root as moon. We didn't just observe the moon. We organized time itself around it. And in the deep future, Long after everything we've ever built has turned to dust, and then to atoms, and then to nothing, the moon will still be out there, farther, dimmer, quieter, orbiting a silent Earth, still keeping its one face turned toward a planet that doesn't have anyone left to watch it. The moon isn't leaving us dramatically. It's not fleeing. It's drifting. The way all things drift eventually from the things that once held them close. And honestly, the only question that matters isn't when the moon leaves. It's whether we'll look up enough times before it does. If that left something heavy in your chest, that weight is real. Subscribe. There's more where that came from. The day the moon leaves Earth, and what happens to us. The moon is drifting away from Earth right now. 3.8 centimeters every year. That sounds harmless, it isn't. In this